Here is also the latest development in humanoid robotics, the Agubot Expedition A3, an experimental next-generation robot created to demonstrate how far the physical side of artificial intelligence has progressed. What you see is not just an impressive show with strikes and acrobatic elements, but a display of extremely precise balance control, dynamic body stabilization, and coordination of dozens of actuators working synchronously in real time. Behind the Expedition A3 stands Agubot, a company focused on embodied AI, where intelligence exists not only in code, but in the robot's physical body. The machine analyzes the position of its center of mass, predicts motion trajectories, adjusts posture on the fly, and compensates for inertia, much like a human athlete. Such feats are impossible without a combination of powerful servo drives, force sensors, LiDARs, and neural network models trained on thousands of hours of movement data. Today, this looks like a technological showcase, but tomorrow these developments will form the basis for robots capable of safely working alongside humans. In industry, warehouses, rescue operations, and even everyday urban environments. We can also see the latest development in the field of biomimetic humanoid robots, a project by Headform, a company that is betting not on virtual avatars or neural networks on a screen, but on fully physical, realistic machines capable of interacting with humans in the real world. This robot is not a concept and not CGI. All footage is captured live, without computer graphics, meaning this is a real technological object rather than a futuristic visualization. Headform is developing so-called natural interfaces for humanoids, a complex system of facial expressions, micro-movements of the face, eye reactions, lip synchronization with speech, and fine motor control of the neck and head. In essence, engineers are trying to bring the robot's appearance and behavior so close to human that interacting with it no longer feels like interacting with a machine. The Origin M1 model is being created as a platform for future assistants, operators, consultants, and companions, from reception areas and service centers to laboratories and demonstration spaces, while inside it houses complex mechatronics, actuator systems, pressure sensors, and cameras that allow the robot to read human reactions and adapt its behavior accordingly. We also see one of the clearest demonstrations of real progress in humanoid robotics. Holiday Robotics showcased its robot Friday in an industrial scenario, transporting and sorting containers in a working environment without human involvement. At first glance, the task seems simple, but it is precisely these everyday operations that remained a weak point for robots for years. Here, Friday operates autonomously for more than 6 hours in a row, consistently performing repetitive actions without failures, which already represents industrial reliability rather than a laboratory prototype. Friday uses computer vision for object recognition, real-time motion planning, and adaptation to small positioning errors. This approach opens the door to universal humanoid workers in warehouses, factories, and logistics. In essence, we are witnessing a transition from show robots to systems that are ready to work in the real economy within the next few years. Here we see one of the most illustrative demonstrations of how rapidly physical artificial intelligence is evolving. At CES 2026, Sharpa North presented fully autonomous robots that do not merely execute pre-programmed movements, but analyze their surroundings in real time and make decisions without human involvement. In the first case, the robots play table tennis against a live human. They recognize the ball's trajectory using computer vision, instantly calculate strike speed and angle, and then coordinate manipulator movements with millisecond-level precision. This is not a spectacle for entertainment, but a demonstration of how AI learns to work with fast, chaotic objects in a real environment. Such technologies are a step toward fully autonomous factories, warehouses, and service robots that will be able to work alongside humans, learn new tasks, and take on complex physical labor in the near future. In front of us is the latest development in industrial humanoid robotics, the HMND series robot from the British company Humanoid, which in recent years has become one of the most ambitious players in the physical AI market. Unlike typical laboratory prototypes, this humanoid is being built as a practical tool for the real economy, factories, logistics centers, and automated production. The company is not focusing on flashy appearance, but on the speed of platform evolution. New robot versions are developed in a matter of months. The architecture is modular, with manipulators, sensor systems, vision, power electronics, and the neural control block all being upgraded independently. The main emphasis is on training the robot through simulations and real-world practice, so it can adapt to environments, work alongside humans, and perform complex manipulations without rigid programming. In effect, we are witnessing the emergence of a new class of machines, physical AI agents that combine mechanics, computer vision, and large language models. If these technologies reach mass production, humanoid robots could become as fundamental to future industry as industrial robots on assembly lines are today. This is not just a show collaboration, but a demonstrative experiment at the intersection of creative industries and industrial robotics. In this project, a human works side by side with a full-size humanoid robot created by 1X Technologies, one of the fastest-growing startups in physical AI. Robots from 1X are designed from the outset not for exhibitions, but for real environments such as warehouses, factories, and service tasks. Their key feature is the combination of precise mechanics, tactile sensors, and neural network control, which allows the machine to safely interact with humans in a shared workspace. In such demonstrations, the company shows not a trick, but the potential of cooperation. The robot can hold tools, stabilize objects, mirror operator movements, and learn new actions through observation. In front of us is the latest development in service and industrial robotics from the Chinese company Limx Dynamics, one of the most ambitious humanoid robot startups in Asia. Formally, it looks like a show performance at a major festival in the Greater Bay Area of China, but in essence, it is a public demonstration of how far modern robots have advanced in motor skills, balance, and movement coordination. Limx robots are built around high-precision actuators, dynamic stabilization systems, and neural network motion control algorithms. In fact, such performances are crash tests for future humanoids, where robots are tested in complex dynamic scenarios, with people, light, noise, and unpredictable surroundings. And if a machine performs confidently on stage, it means it is almost ready for the real world. Here we see a real application of embodied AI in industry. Unitry robots are already working directly on the factory floor, assembling other robots. This is not a laboratory experiment and not a promotional video, but an operating production line. At the core of the system is the Unifo LMX10 model, which allows the machine to understand its environment, recognize components, precisely manipulate objects, and adapt to changes during the assembly process. In effect, we are witnessing the beginning of a new era of automation, where robots do not simply execute pre-programmed motions, but learn from experience, correct their own errors, and accelerate production without human involvement. And it is precisely such factories that are becoming the foundation for the mass production of humanoid robots in the coming years.